In this video, I'm going to go over constructions and angles as a review for our Unit 2 test. Define the term perpendicular lines. Perpendicular lines are lines that intersect to form right angles. A perpendicular bisector is a line or segment that intersects a segment at its midpoint and at a right angle. A line or segment that intersects a segment at its midpoint and at a right angle. So perpendicular lines, they just hit each other at right angles. Perpendicular bisector cuts a segment into two equal parts and it hits it at a right angle. And let's just see one example of what the construction for a perpendicular bisector looks like. So I'm going to use the safety compass to do this construction. First thing I'm going to do is center it at one point, and as long as the slider actually just goes past the halfway mark of this line, it should be fine, but I usually like to bring it all the way to the other end. So I'll line it up so I'm at the center and that my slider is up on the other end of that line. And then I'm just going to draw an arc above and an arc below. Once I've got that, I'm just going to take this and spin it around, center on the other point, go to the point that I was just centered on before, and an arc above and below. Where those two arcs intersect, that shows me where my perpendicular bisector is going to be, and I'll just draw that line in. And that is now hitting this at the midpoint, so these two sides are equal, and it hits at a right angle. This other one is just for practice, but I'm just showing you an example of how to do it, so maybe practice on both of these here on your own sheet. Next, we've got the term angle bisector. An angle bisector is a line or line segment that cuts an angle into two equal parts. Line that two equal So an angle bisector is a line that cuts an angle into two equal parts. Here are two examples, two pictures that you can use to do angle bisectors on. A lot of students know how to do this and they get here and they get freaked out. It's the same set of steps for each of them. I'm going to do this one just because this is the one that students mess up on a lot. So first thing I'm going to do is center on this point, and my slider can really be whatever size I want it to be for this. So I'm going to make it that big. Why not? All right. Center it, and I'm going to draw an arc that's going to hit at least both of the sides of my angle. So right here, and I'm going to continue it. More or less. All right. The two places where my arc hits my angles, I'm actually going to just, if you think of it, and I'll draw a really, really faint line here, I can make a line between those 2 points. If I make a line between those 2 points, if I just do a perpendicular bisector of this line, it will get me my angle bisector. And you can do that for any angle bisector. I can start by drawing the circle centered around here, and if I do a perpendicular bisector of the line where it hits, I will get my angle bisector. Now, just to continue the steps though, if you want, you can just say, oh, I see this line, I'll make a perpendicular bisector, it's good. If that's confusing you, well then just keep following from here. I drew a circle centered around here. I got 2 places where it hit my angle. I'm going to center it on one point, go over to the other, and draw an arc above it. And once I've got that arc, I'm going to spin it around and do the same thing on the other side. Center on the opposite point, just like we do with an angle bisector, or a line bisector, perpendicular bisector. And right there. Where those 2 arcs hit each other, I'll make a point, and from the vertex to that point, I'm going to draw my angle bisector. And so now I know that this part of the angle should be equal to that part of the angle, because I bisected it. Let's move on to the next page, or maybe I'll give just one moment of clear shots of this entire page in case you want to pause and take a look at how it's done. All right, let's move on to the next page now. All right, we are going to start out by defining the term parallel lines. Parallel lines are lines that are always the same distance apart. And that means that they're never going to touch. So parallel lines are lines that are the exact same distance apart always, and that they never ever touch each other. All right. Now, to talk about a construction of a parallel line, there's really 2 ways to do it, and I kind of want to show both in this video. The first way to construct a parallel line, actually, well, maybe I'll still do it on this page. The first way to construct a parallel line is to think about our rules with transversals. If you can recall, a transversal is 2 parallel lines. Well, a transversal doesn't need to be 2 parallel lines, but we always see that way in geometry class. If I've got 2 lines that are parallel, and then a line transversing through the 2 of them, I know something special about the angles over here. I know that if this angle is, let's say, 30 degrees, that the corresponding angle is 30 degrees, its alternate interior angle is 30 degrees, and that the opposite angle is 30 degrees. All of these would be 30 degrees. So we're going to use that fact to help us build our parallel line. First thing, I've got one line. Now I'm going to actually draw my transversal first. So as long as I just start out by drawing a line that intersects this line and goes through that point in any way, it's going to work out. So I'm just going to draw a line like this, so it kind of will look like our transversal that I just drew over there. Now what I want to do next is I want to copy this angle up here, and if I do that, well, I'll know that these 2 lines are parallel. First thing I'm going to do is I'm going to draw a circle of any size that I want around this point right here. I'm going to make it kind of small so it doesn't go too far outside of this box. All right. And usually, yeah, it's going to help. Make sure that your slider isn't going past the point up there. It's going to be kind of weird if you do. And I will draw my circle now. All right. Once I've done that, I'm going to draw a second circle centered around this point of the exact same length. So I'm not adjusting my compass anymore. Circle of the exact same radius, I should say. All right, now that I've got that, I'm going to draw 2 points. 1 point right over here where it hits my transversal line, 1 point over here where I'm going to hit the line. And I'll also draw a point where my second circle hits the transversal line. I'm going to measure the distance from the point on the transversal line to the point on my starting line, which came out to being almost pretty much the same. And once I have that measurement, I kind of like to just draw this little arc out over here because it kind of helps visualize, but I really don't need to be drawing an arc right now. I've got this, so you see I measured that distance, and I'm just going to keep that same distance, go up to the point that we intersected with on our circle, and make another little arc right onto there. And where this new arc hits the circle that I just drew, I've got the 2 points that I need to create my parallel line. Now if you've got a nice compass, it's going to actually come out parallel, and if you've done this all right, these 2 lines should really end up being 2 parallel lines. And I've copied this angle to up there, and that helps me create this parallel line. Now the other method I'll save for another video after this sheet because I don't want to spend too much time more on this sheet. All right. Explain the justification for above. Well, I copied the angle and corresponding angles in a transversal are congruent. That's the congruent sign, are congruent if and only if the 2 lines being transversed are parallel. So I copied the angle, and the corresponding angles in 2 parallel lines, the corresponding angles in a transversal are only congruent if these 2 lines that are being transversed are parallel. All right, an inscribed shape is a shape such that all corners of that shape are touching the edge of a circle that the shape is inside of. Construct. So, inscribed shapes are shapes such that all the corners of that shape are touching the edge of a circle that the shape is inside of. A quick example of what that looks like, in case that description is kind of weird, is here I've got a circle, and an inscribed shape is inside of the circle, and all the corners of that shape are touching the edges of that circle. So this is a square inscribed inside of a circle. Now we're going to see some constructions on how to make these inscribed shapes. First thing I need for any of these is a circle to put my shape inside of. So I'll make a point, and I'm going to do my best to make a circle all the way around. That wasn't that painful. Once I've made the circle, what I now need to do is just draw a diameter through that circle. So just a line from one edge to the other that hits the center of that circle. This is for drawing a square inscribed inside of a circle, by the way. All right, once I've got that line, I just need to create a perpendicular bisector to it, and then we're pretty much done. So I'll make really quick this perpendicular bisector. By centering on one end, going out to the other, and drawing my arcs above and below. And then I'll do it again on the opposite side. Center on one end, arcs above and below. All right, and the two places where it hit, that shows me where to draw my line for my perpendicular bisector. And then finally, the 4 places where those lines hit the edges of my circle are going to be the vertices of my inscribed square, or the corners of my inscribed square. So then I'll just connect those points. And over here. So that is my square inscribed inside of a circle. Next, we're going to do a regular hexagon. Again, I'm going to draw another circle. Oops. Yeah, that'll do. I'm going to draw that circle all the way around. First I got to center, and let's draw this circle. All right, now that I've got the circle, what I need to do is just choose a point on the circle to start. I'll choose right over here. And then I'm going to measure out that radius, so from the center out to the edge. I'm going to measure it out. So center on the center, and get the slider. Actually, I really didn't need to move it because I just had the radius from making the circle itself. All right, so I've got that measurement. And now what I'm going to do is center on the point that I made and start making tiny little marks around the edge of my circle. I'm going to try to go all the way around. So center it there, keeping that same radius distance, and I'm never going to change the compass for the rest of this construction. I'm just going to make a tiny, tiny little mark right over there. Where it hits the circle, I'm going to put a second point, and I'm now going to be centering there. And again, I keep the exact same measurement, so this should be the same radius measurement. I'm going to center on the second point that I just made, draw another little mark. Just like that. And I'm going to keep doing this all the way around the circle until I get back to the point that I started at, making sure my measurement is the same. Centering there, and just drawing a little mark. I'm going to do this 2 more times now. Well, 3 more times, sort of. Put another point, and we're almost at the end here. Let's see. Still have the same radius, that the slider hasn't moved at all. Good. Make another point, and then you'll notice after you've made the point over here that if I try to measure this radius again and draw another point, it's going to bring me right back on top of the point that I started out with. So here I've got 6 points on the edge of my circle, and these 6 points are going to be the corners of my hexagon, and I'm just going to freehand it for this one. So here I've got my regular hexagon inscribed inside of the circle. And now the next one over says how to do an equilateral triangle, and that one is really nice, and it's good that we made the regular hexagon first, because all I do for that is I choose some point to start on. Let's say this point over here. And instead of going to the next point, I'm actually going to skip one. So instead of going here, I'm going to skip one, go over here right away, and I'll draw a straight line there. This time I'm going to use the ruler. That's one. Once I get to that point, I'm going to skip one, go to the next one, and I'm going to connect my last point to my first point, and actually it gives me that equilateral triangle inscribed inside of a regular hexagon. So actually this construction, a regular hexagon, equilateral triangle inscribed inside of a circle. But I do that by drawing the hexagon construction and then just doing the 3 points. Let's do our final page over here. I'll leave these two constructions up for a moment so people can pause the video and take a look if they want to try finishing on their own. All right, final page here. Use the diagram below to answer the following questions, or the questions that follow. A pair of corresponding angles here would be, well, let's see, this angle over here and this angle over here are corresponding angles because they're in the same part of the two intersections that kind of match up here. So it's the bottom left and the bottom left, if you see the two boxes I made. So this is angle ABE is corresponding with angle DEG. A pair of alternate interior angles, well, that means on alternate sides of the transversal and on the inside of my two parallel lines. So using ABE again, this is going to be my alternate interior angle. So FEB, angle ABE and angle FEB. All right, moving right on. Supplementary angles are two angles that sum to 180 degrees. And taking a look at my diagram up here, I know supplementary angles are two angles that add up to 180. And also, if I've got a straight line, that's a 180 degree angle. So if I take this angle and add it up with that angle over there, I've got a pair of supplementary angles because these two angles add up to make a straight line, which means they're adding up to make 180 degrees. So that's angle ABE with angle CBE. Angle ABE and angle CBE are supplementary angles. Let's get the new blank sheet of paper underneath this because I have those Sharpie marks popping up. All right, we're almost done with this. If the measure of angle ABE, is 72 degrees, find the measure of angle BEF. Well, we already said that ABE and BEF, or I called it FEB, are alternate interior angles, which means that they're congruent. So that means that the measure of ABE is 72, so BEF must also be 72 degrees. If the measure of angle DEB is 125, find the measure, so DEB, that's this angle right over here, find the measure of angle ABH. Well, these two angles are corresponding angles, and since these two, ABH, since these two angles here are corresponding and these two lines are parallel, we kind of are assuming they're parallel even though they don't say, that means that these two are also congruent. So ABH is going to be 125 degrees. All right, let's keep moving on. If GEF, I'm going to start running out of colors. If angle GEF is 3x plus 45, and angle EBC, my two purple angles here. And if that is 5x plus 25, what's the value of x? Well, I know these two purple angles are corresponding, which means they're congruent. So I can just take this, set it equal to that, and do the algebra. Which, why not? We'll do it in purple. 3x plus 45 is equal to 5x plus 25. And let's start doing the algebra. I'm going to get minus 3x to both sides. 45 is equal to 2x plus 25. Take away 25 from both sides. 45 minus 25 is 20, is equal to 2x. So that means that 10 is equal to x here. And that's my answer. They wanted to find the value of x. I found that x is 10. One more on this before we're on the final section. If the measure of, and we'll do our last color, just ran out of colors. If the measure of angle CBE, so now I'm going to do CBE in green. If the measure of angle CBE and angle DEG, ooh, I could use these colors better. CBE and DEG are equal to these two expressions. Find the value of both angles. Well, CBE and DEG, they're not equal. But I do know that CBE is equal to, we just saw in the last question, GEF. And I know that GEF and DEG, that these two angles together make 180 degrees. They're supplementary. So if I take, well, this angle is equal to that. So let's say this was, what did they give us? X plus 20 over here. Well, then this is going to be x plus 20. And they also gave us that DEG is 2x plus 10. 2x plus 10. And I know that these two angles together need to add up to be 180. So let's do that on the bottom over here. So I've got x plus 20 plus 2x plus 10. These two angles together need to add up to equal 180 because they are supplementary. I'm going to combine like terms, and I'm going to go to the right because I don't have space. So I'll get 3x plus 30 is equal to 180, which leaves me with, I'm going to take away 30 from both sides, minus 30, leaves me with 3x is equal to 150, which means that x is equal to 50 because I divided both sides by 3. But it wants me to find not x, but the value of both angles. Well, if x is 50 and I've got x plus 20, the measure of angle CBE over here is going to be 50 plus 20, which is 70. And then I've got DEG over here. Well, 2x plus 10. 2 times 50 is 100. Plus 10 more is 110. And hey, that works out. 70 plus 110 gives me 180. Whew. All right. Almost done with this. Find the measure of the angles in the triangles below. I'm going to do these first three, and this fourth one we haven't really looked at yet, so I'm going to let you know you don't need to worry about that one for the test. 2x plus 9x plus 4x. Well, I know that the measures in a triangle must add up to 180 degrees. So now I know that 2x plus 9x plus 4x have to equal 180. I'll combine like terms. This is going to be 6x. This is 15x equals 180. I'll divide both sides by 180. Sorry, divide both sides by 15. And I'll just put this in my calculator really quick. (180) divided by 15 is equal to 12. So I found that the value of x is 12, which means that, well, 2x, 2 times 12, this angle is going to be 24. 9x, 9 times 12 is 90, 99, 108. And then 4 times 12 is 48. And these three should add up to be 108 plus 24 plus 48 gets me 180. This question right here is the same idea, just a little bit more, algebra to do, but it's the same thing. I've got 2x minus 4 plus 5x plus x plus 12 has to equal 180. I'll combine all my like terms here. 2 and 5x is 7x plus 1 more x gets me 8x. Negative 4 and 12 is now plus 8 is equal to 180. I have to subtract 8 from both sides, and I get that 8x is equal to 172. Divide both sides by 8, and 172 divided by 8 is leaving me with x is equal to 21.5. I will leave it to you to put that in there, but we should be getting that all three of these angles add up to be 180 degrees. And the final question we're doing for this is this triangle right over here. I've got 142 degrees over here. Well, these two lines go together to make a straight angle. So that means these two need to add up to 180. So that tells me this angle over here is going to be, well, 180 minus 142 will get me that angle over there. Or you can think of it as, if I say this is y, that 142 plus y equals 180. It's the same thing, really. And I'm going to get that 180 minus 142 is, this angle over here is 38. This angle marker over here means that it's a right angle, which means that it's 90 degrees. And so I've got 90 plus 38 plus x is going to get me 180. So 90 plus 38 is 128. 180 minus 128. This angle over here, x, should be 52. Try the algebra on your own here. The equation I would have gotten is 90 plus 38 plus x. Let me draw it out on a piece of paper over here. And the equation I would have gotten would have been 90 plus 38 plus x equals 180. And I do that, that becomes 128 plus x equals 180. Minus 128 on both sides, and x is going to have to be 52. All right, that's it for this video. I hope that helps you in reviewing for your test.